Hello, everybody. I hope you're all doing well. Here is the chi-squared goodness of fit test right here. The problem is the same as the first page. Benny tosses a fair dice 90 times. The results are as follows. Find the expected frequencies, write down the number of degrees of freedom, and here's the critical value, and determine the results of a goodness of fit test at 1% to find out whether Benny's data fits a uniform distribution. Remember to write that down, the null and alternative hypothesis. Okay, well, I'll start with the null. I'll start with the null and alternative hypothesis here. On the first page, Benny right here. Okay, yeah, pretty straightforward. The data satisfies a uniform distribution. They are equally likely to land on 1, 2, 3, 4, 5, 6. That's what this dice is. So I'm going to, bam. Okay, we have our null and then our alternative. Can I do that? Yes, data does not satisfy a uniform distribution. Okay, so our expected frequencies, for goodness to fit, we need to figure out our expected frequencies. How do you spell frequencies? Yeah, all right, there we go. Okay, so Benny tosses a fair die 90 times, and if this is a fair dice, then it should fall equally on 1, 2, 3, 4, 5, and 6. So I'm looking at doing 90 divided by 6, which, if I'm not mistaken, is 15. I am going to double check that so that I don't make a mistake. 90 divided by 6 is 15. I proved it. Okay, so 15 is our expected amount for each one. Um, each number should show up 15 times. Okay, write down the number of degrees of freedom. That's right, degrees of freedom. Um, for goodness of fit, you just do one less from the number of columns. So 1, 2, 3, 4, 5, 6. So that'd be 6 minus 1 is equal to 5. And that should be our degrees of freedom right here. Now let's do our hypothesis test right here. 1% significance level. Let's remember that is not 5. I'm going to forget. Okay, let's go back to my calculator right here. I have to exit. Okay, cool beans. I have another test in here right now. I'm just going to delete that really fast. There's probably a better way to delete that I'm not aware of, and I will learn more about that. So list 1 will put our observed data in. So 13, 15, 17. 13, 15, 17. 16, 14, 15. 16, 14, 15. Cool. And in list 2, we'll put our expected data right here. That was 15 every single time. 15, 15, 15, 15, 15, 15. Okay, I think I have everything ready to rock and roll. Let's do this. Press F3 for a test. We're going to do a chi goodness of fit test right here. Observed is list 1, expected list 2, degrees of freedom is 5. Yeah, okay. That just confused me. I thought that would be there automatically. Interesting. And it's going to post things in list 3. All right. I will go to execute, and let's see. S-squared S statistic is 0.66. Oh, p-value is 98. Holy, 0.98. That is a very, I guess, look at all these numbers. They are very close to 15. Um, so that, I guess, that doesn't surprise me. Okay, so the chi-squared, do they ask for the test statistic? They don't. They just determine the results of the goodness of fit test. So if they don't ask for it, I'm just going to say the p-value is 0.98. Wow, that's a high p-value. And because the p-value is greater than the significance level, here, and we will accept the null hypothesis. The data does satisfy a uniform distribution. Okay, doke, folks. Thank you.